This short little tutorial is going to be on Williamson's reaction. Williamson's reaction is a reaction that we use for the preparation of ethers. And the basic reaction includes the use of a sodium alkoxide, which we saw in the other video tutorial of alkoxy groups. It includes an alkyl halide, where we are using the alkyl represented by R hyphen and the X is any halogen. Remember, X can be chlorine, fluorine, bromine, or iodine. And these react to produce an ether, where we get both of the branches attached to the oxygen, plus a sodium salt. An inorganic sodium salt, which is where the halogen goes. This reaction is a double replacement reaction. Let's look at a specific example. Let's say we start off our reaction with sodium, and then here we have isopropyl, and we're going to add ethyl, and here we have chlorine, and these are going to react to produce. We have oxygen in the middle, separating an isopropyl, and separating an ethyl group. And at the end, what happened? The sodium and the chlorine came together to form this. So now, when we do the naming, remember, first let's analyze. Here we have sodium, and here we have sodium. That's where they went together. Then we have the chlorine, and the chlorine goes to the end. Then here we have this isopropyl, which showed up here. And last but not least, we have the ethyl group, which showed up here at the end. So they switched partners, and now we can easily do the naming. Here we have the sodium alkoxide, which is sodium isopropyl, isopropoxy, isopropoxide. Sodium isopropoxide reacted with ethyl chloride, because remember it's mixing, so the ide ending. And then at the end we have, using the common name is going to be ethyl isopropyl, ethyl isopropyl ether. And then at the end we have our traditional sodium chloride. Now, if we use UPAC name for this ether, we look for the longest chain, 1, 2, 3, 1, 2, so it's this side, and this is 2-ethoxy propane. This is UPAC, and the top is a common name. A common name, okay? And just so that we make sure that you guys got it, I'm going to do another quick example. We'll look at this. We grab again our marker, and we have sodium. I'm just going to make up anything that comes up in my mind right now. Let's see. Let's do something funny. Fluorine. Okay, so this is what you would get maybe on a test or a quiz. So you analyze and you're like, wait, the only reaction that uses sodium alkoxides is Williamson's reaction to produce ethers. And I remember that the sodium goes with the fluorine to make a salt, and then the two branches attached to the oxygen to give me the ether. So let's analyze what we have here. We have sodium, 1, 2, 3, 4, 5 at the secondary carbon. So this is sodium sec pentoxide. And here we have 1, 2, 3, 4, 5. This is 5 carbon atoms ending in this chicken foot shape. So this is neopentyl fluoride. So now we have our groups attached. So let's use that little marker technique again. I'm going to highlight this, and I'm going to highlight the fluorine. And these two are going to show up together at the end of my formula. So we have sodium fluoride, and we're going to name it sodium fluoride. And then what's attached to my ether? We have oxygen in the middle, neopentyl on one side, 1, 2, 3, 4, and 5. Neopentyl, check. And on the other side, we have sec-pentoxy. So sec-pentoxy is going to be sec-pentyl 1, 2, 3, 4. 1, 2, 3, 4, 5. Sec-pentyl, neopentyl. I'm just going to highlight that for you guys to notice. Here we have the sec-pentyl. Here it is again. And for the other one, we have neopentyl. And this neopentyl shows up right here. So the name of this ether using common names is pentyl, pentoxy, pentyl. Both of them are pentyl. So neo comes before sec. Yes, it does. So this is neopentyl, sec-pentyl, ether. And that's it for this video on Williamson's reaction.